Here's problem 2414. A charge of 8 picocoulombs is distributed uniformly on a spherical surface, raised 2 centimeters, and a second charge of -3 picocoulombs is distributed uniformly on a concentric spherical surface, raised 4 centimeters. Determine the magnitude of the electric field 5 centimeters from the center of the two surfaces. Let's take a two-dimensional cross-section of what's going on here. Try to graph this. 1, 2, 3, 4, 5. So we have one sphere. Let's put it in green. Radius 2 centimeters. Looking as best as I can draw it. The charge on this sphere, let's call it Q1, is equal to 8 picocoulombs. Then we have another sphere, radius 4 centimeters. And the charge on this sphere, let's call it Q2, is equal to -3 picocoulombs. So we have an inner sphere that's positively charged and an outer sphere that's negatively charged. And the charge is residing on the surface of these spheres, so they're both acting like shells of charge, because all the charge is on the surface just like a shell. We have a point at x equal 5 centimeters, as I've drawn it, and we wish to calculate the electric field at that point. Well, we will employ the principle of superposition on this problem, find the electric field due to each of these charges separately, and then superimpose them together. Now in this case, we are outside both of these spheres, and when you're outside of a shell of charge, in this case, the shell acts like a point charge with the location of that charge at the center of the shell. So this first shell is acting like a point charge located at the very center of this origin, 8 picocoulombs there. And the second distribution is acting like a point charge, also located at the center of its shell, -3 picocoulombs there. So if we were to rewrite this problem, we can think of it something like this. Point P here located at x equal 5. We actually have two charges located at the center, in a sense, point charges. One of them positive, one of them negative. And the positive one is 8 picocoulombs, and the negative one is -3 picocoulombs. And we wish to find the electric field at 5 centimeters away. Well, then our total charge is going to be Q1 plus Q2, and that will be 8 picocoulombs plus a -3 picocoulombs, 5 picocoulombs. And our electric field will be equal to K times our total charge, acting like a point charge, over R squared. So this will be 9 times 10 to the 9 times 5 picocoulombs, 5 times 10 to the -12, over the distance to that point, point P, which is going to be 5 centimeters squared. So I could write this as 9 times 5 times 10 to the -3 over 5 times 5 times 10 to the -4. One of the 5's cancels out. So I have 9 divided by 5, which is 1.8 times 10. So this would be equal to 18 newtons per coulomb. As I've drawn it, it would be outward from that point. So at point P, we're looking at an electric field that's going radially outward with a value of 18 newtons per coulomb. 18 newtons per coulomb from that point.